Let's say you had the sine of something equal 3/5, and you had to figure out what that something was. How do you undo sine? What did you have to do on the calculator? The inverse. You'd use the inverse trig function. We did a little bit of this at the very beginning of this section as well. You knew that that angle would equal the inverse trig function of sine of 3/5, and you'd get some decimal and go on your merry way. Well, that's kind of what we're doing here now, but we're not dealing with crazy decimal values. We're going to be dealing with really just ones that work out into being the special right triangles. Because that's all we can do without a calculator. We're not going to be doing stuff with the calculator yet. We will eventually. We'll come back and do a little bit of this weird stuff with the calculator. But right now I'm trying to get everything without. But what happens here is, can I go to the table real quick? I'll show you something. What happens here is if you go into our unit circle, and if I'm here at a 30-degree angle, I'm also here with a 30-degree reference angle. You guys okay with that? These two values have the exact same sign, don't they? The sign at 30 is 1/2. We know that the y values there are going to be the same. So if I ask you what angle has a sine value of 1/2, you would say, oh, it's 30 degrees or 150. Which of those is going to be correct? And that's what we start talking about here today. It's working backwards out of it. Now, when you work backwards out of trig functions, there's going to be specific rules that you have to follow as far as what values you're going to be looking for within the oscillation. What I mean by that is going around the circle if you put it out linearly and see stuff like this and so on. So, excuse me, there's a few rules. For values of sine, when we're trying to figure out what values of sine, the sine of an angle that we're trying to search for, we're going to search for theta is going to be somewhere between pi over 2 and negative pi over 2. What this looks like is here. We search for sine between those two quadrants. By doing that, that gives you all of your positive values you can get, as well as all of your negative values you can get. And I'll do examples of all this stuff as we go through. It winds up, once you see a couple of examples, you're like, oh. So we'll search for sines in those two quadrants. Example really easy would be what? Hey, look at cosine. When we search for cosine, sine. So, yeah, sine. When we search for sine, we're looking for values. What angle has a sine value? We're going to find those angles somewhere between pi over 2 and negative pi over 2. With cosine, we go between 0 and pi. Because cosine's positive in the first quadrant, negative in the second. So cosines are the only ones that we can get obtuse angles out of. Excuse me. And notice we're including 0 and we're including pi. Which leaves us, what do we have left to look for? Tangent. Tangent's the weird one. Remember when we graphed cosine and sine last week, and I showed you guys that sine went up, down, and came back like this? Cosine started up top, worked its way around, and stopped up there. Then tangent was the weird one. Tangent was these two were both cosine and sine graphs were always continuous. They never moved. They always kept moving and moving. They oscillated all the way through. Whereas tangent was weird. Because if you go through your values of tangent. And when we talked about it before, when we graphed cosine and sine, we graphed them via the quadrantals. If we did that with tangent, we had 1, 0, 0, 1, negative 1, 0, 0, negative 1. If we went through these guys, it did all of our points for tangent. We knew that at 0, it's y over x. What's 0 divided by 1? 0. Okay. At pi over 2, if I go up to pi over 2, it's 1 divided by 0. Can I divide by 0? So what would be the tangent at pi over 2 be undefined. When you graph something that's undefined, what do you put? An asymptote. Okay. If I move this direction, I would go to negative pi over 2. You guys okay with that? If I go to negative pi over 2, it's also undefined. What's halfway between pi over 2 and 0? Pi over 4. Pi over 4 is what kind of an angle? It's a 45. In a 45, 45, 90, that's a 1, 1, and a root 2. What's the tangent at 45? It's 1. What's the tangent at negative 45? Negative 1. So what happens here at halfway points, you get stuff that looks like this. Tangent's weird. Tangent is not continuous. It's not continuous because it's got the asymptotes. Okay? And it works its way through. So what happens here with tangent, when we're searching for angles that have values of tangent, what we're doing is that we're still looking at that range between pi over 2 and negative pi over 2, but we don't include pi over 2. It's like the open circle. Okay? It's less than. It's greater than. So we're looking for values that are less than pi over 2, but greater than negative pi over 2. So these values here will be greater than negative pi over 2, but they'll be smaller than pi over 2. Whereas the sine ones that we wrote down, we included that because they said they could equal those. Here they can't, because you have asymptote. You can't do it. You can't divide by 0. Bless you. So what this is going to be able to do is something really, really, really simple. For example, we're going to have a value this says what angle has a sine of root 3 over 2? What angle has a sine of root 3 over 2? That's what this means. This means what angle has a sine of root 3 over 2? A root 3 over 2, is that root 3 over 2 positive or negative? It's positive, so that means it's going to be in the first quadrant. If I'm root 3 over 2, that means that my opposite is root 3. Right, Nelson. My hypotenuse is 2. What angle has an opposite of root 3? 60. So what angle has a sine of root 3 over 2? 60. Your answer is 60, or in radians, 3. Very good. That's what that means. What angle has a sine of root 3 over 2? Notice we still drew the picture of where does it occur, what quadrant does it lie in, where am I searching for it? Well, I'm searching for sine values. When I'm searching for sine, I'm looking either in 1 or 4. If I'm in 1, I'm looking for positive values. If I'm in 4, I'm looking for negative values. That's what that means. All right. Let's try another one. What angle has a cosine of 2? Does cosine ever get larger than 1? Does sine ever get larger than 1? Can tangent be larger than 1? Yes. Does this occur? No. Nope. Cosine, you can't get an angle that has a cosine larger than 1. Remember, the maximum value for angles for cosine and sine are always going to be, they're within your circle. What's the maximum value? Always going to be 1. It doesn't get larger than 1. Cosine and sine will always be less than or equal to 1. They're always, I'm sorry, the cosine or sine of any angle will always be within the range of -1 to +1. Yes, sir. That's fine, or undefined. Gnomes, sad face, taking my ball and going home. Thanks for chuckling, Devin. Or was that you? All right. What about this? Let's try another cosine. What angle has a cosine that's equal to -1/2? What angle has a cosine that's equal to -1/2? Sine, yeah, sine and cosine can, because then you're on your quadrantals. Where is cosine going to be negative when I'm looking at those parameters? It's going to be my second quadrant. Remember, when we're searching for what angle has, that means I'm looking at it between here and here. Okay. It being -1/2, that means my adjacent is -1, and my hypotenuse is the 2. What angle has an adjacent of 1 and a hypotenuse of 2, which means its opposite is 30. So this is a 60-degree reference angle, but I'm in the second quadrant, which makes this angle how much? 120. So your angle is 120. Or, in terms of radians, you're pi/3 up, which means you are 2 pi. 2 pi/3. It's not going to be 3 pi/2 because if it's 3 pi/2, you would have dropped down to the third quadrant because it's more than a pi. You're less than a pi. Okay. Well, 3 pi/2 would have been at 270, so I was wrong in saying that anyway. Yep. When you're a reference angle of 60 degrees, you're in the second quadrant, means your actual theta value is going to be obtuse because cosine is the only one that gives you obtuse angles. So there's your answer. What angle has that? What angle has cosine of -1/2? 120 degrees or 2 pi/3? Well, the reference angle gets you placed into what triangle you are. When you're in the second quadrant, you're talking about a cosine. That means this has to be 120 degrees to go to second quadrant. Cosine is the weird one that will give you the obtuse angle. Yes, sir. Yep, because that's the terminal side of the reference angle of 60. Is that where you're getting at?
Yeah,
I don't remember saying 30. If I did, I.
No, you said 30,
Oh, okay, okay. Guess what? I got one. Like, okay. Cosine is the only one that's going to give you an obtuse angle. Okay. Let's try another one. Yeah, I'm not getting any crazier than this. What angle has a tangent of -1? What angle has a tangent of -1? No? We just said this. Tangent can. So, no. Cosine and sine has to be less than or equal to 1. Tangent can be greater than or smaller than -1. Remember? We just graphed it like 2 seconds ago. Where's tangent negative 1? You know, there's reasons why I show examples of what happens. Tangent was negative 1 at what degree? Well, it's negative, so it'd be negative 45. You go back to the side. So remember, tangent, in order for tangent to be 1 or negative 1, I swear you're worse than somebody over on the other side of the room. He's worse than you, and that's impressive. Anyway, when you have a tangent value that's 1, that means, what's up? Thank you. Is there money here for me? Oh, actually, it's for me. Never mind. Thank you. So, when you anyway, in order, tangent is opposite over adjacent. If it's opposite over adjacent, and they're in order for it to be equal to 1 or negative 1, they have to be the same ratio. They have to be the same sides, which means it being negative, it went down here, which gives you a 45-degree angle here, negative 1 and 1. Tangent is found between pi over 2 to negative pi over 2. And this is going to be at negative pi over 4. Yes, sir. It will, but in this case, when we're searching for stuff just like this, we're looking for this only specific parameter. Devin, I think I already posted the homework. See you, buddy. So when we get to stuff probably on Wednesday, Colby, it will change it up to, we'll say within what angle has a tangent of negative 1 when I'm within a full revolution, and then I'm going to list all of them. But for now, when you're searching for, when your calculator did that stuff when you did right triangle trig, notice how it always searched for angles with it. You never got weird angles. This is kind of why it was doing that. When we get into it later, then we're going to open it up to all revolution. Then we're going to look at it for what's called general solutions versus one revolution solutions, and it gets a little muddy after that. We'll get there. We're not there yet. Remember this. All students take calculus, and that will get us there. We're a couple days from it, man. Don't worry about it yet. Seriously, don't worry about it. Yes, ma'am. I put negative 45 because remember, when you're searching for theta for this case theta for tangent is smaller than pi over 2. Oops. But greater than negative pi over 2. So that's why I say it's a negative 45 or negative pi over 4. Same question. Video. Huh? If the question was, the answer is always negative pi over 4 if the question is what angle has a tangent of negative 1. So you're partially, some of that was there. Yes, sir. No. Sine is still pi over 2, negative pi over 2. Cosine is 0 and pi. You're thinking about maximum values. I'm talking about what angles. Okay? You're thinking maximum value. I'm thinking about what angle. Let me show you a couple more. No. There's only so many angles. How many angles are really on the unit circle? If you really think about it, you have 0. You have to have a calculator. I mean, really get into it. You only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I think I forgot to count. I think there's only 18 possible angles. Yes, ma'am. Yes. Okay. What angle has a tangent of root 3? What angle has a tangent of root 3? Which, what angle has a tangent of root 3? So if I'm looking at that, turn this off real quick. It's positive, which means I'm going to go first quadrant. What angle has a tangent of root 3? That means my opposite is root 3. My adjacent is 1. What angle has an opposite of root 3 and adjacent of 1? 60. So it's 60 degrees. Or in radians, it would be pi over 3. Yes, sir. Yes, it says that in the instructions. It said give them with radians and with degrees. I'm always going to say that. Okay. That's good. For sine, yes. Oh, I'm sorry, for tangent. I thought we just did sine. Yes, yes. Tangent being positive first, negative in second. Or I'm sorry, fourth. Mm-hmm. Yep. Cosine root 2 over 2. Which triangle has root 2's and 2's? 45. So when you have root 2 over 2, that probably tells you that something's been rationalized, correct? So what's the unrationalized version of root 2 over 2? 1 over root 2. So here's your 1, here's your root 2. What angle has the 1 adjacent and the root 2 as the hypotenuse? 45. So that means that this angle is 45 degrees, otherwise known as pi over 4. What angle has the cosine? What angle has the sine? Yes, ma'am. It's going to be 45, but just got to be careful. Is it going to be 45 or is it going to be 135? That's kind of the trick. Remember the other day you went, oh! You're still doing that. Oh! It's kind of a dead giveaway what happens a lot of times here. What angle has the sine of 1/2? Let me just do that one. So the sine of 1/2, that's opposite of hypotenuse. Well, that's going to be 1 and 2. That means that's going to be a 30. What's 30 degrees in terms of radians? 5 or 6. That's all we're doing today, guys. We're not getting any crazier than this. Yes, sir.
Do you want us to put our answers in degrees and radians?
I believe I've answered that, yes. The answer is yes. Because that's what they say in the textbooks and all that. All I wanted you guys to do tonight is that we're just going to start this out. I don't have much, like a whole whopping 8. I know. Pace yourself. All I need you guys to do for right now, and yes, you are doing them with radians and degrees. Every time that we search for angles, we're always going to do radians degrees. That's kind of, we'll always do radians degrees, okay? What's that? We're going to do radians and degrees, yes. Now, what Colby was getting at is what happens when we start opening things up to later on. And it will be written differently. We're going to solve equations, and then you'll have stuff that'll say, solve on the interval between 0, theta is smaller than or equal to 2 pi. Smaller than 2 pi, but greater than or equal to 0. You'll see parameters like this where I'll say, hey, 2 cosine theta minus 1 equals 0. I'll ask you to solve that equation. You got to get theta by itself. What do you do first? No. Add what? Okay. Then what? By what? So cosine of theta is 1/2. What do you do to undo it? What angle has a cosine of 1/2? 60 degrees. Now, if I'm looking at it between 60 degrees, cosine is positive in what quadrants? first and fourth quadrant. So if I have a reference angle of 60 here and 60 here, that means that's pi over 3, and this one would be at, but I'm within one revolution between 0 and 2 pi, so I'm going all the way around. Or how about 5 pi over 3? And that would be all your answers within one revolution. So it changes what we're starting out small to build it into this. We'll get there. Tonight, all you're doing is just what we just looked at. Yes, sir. Not a nice person.
So,
Probably not till Wednesday.